Okay, wait, shut up. Let's go through the last one in weight for weight. So, the question is 1.6 mole per liter. 1.6 mole per liter Na2CO3 in percentage weight for weight. What does percentage weight for weight mean? It means effectively the mass solute in mass solution, like 100 grams. How much solute is there in 100 grams of the solution, which effectively says like how much is it as a percentage. Okay, so we already have that it's 1.53 grams per mil, okay, as a solution. So let's work that out. So now we have to get 100 grams. So we need to work out how many mils is 100 grams. So we need to know that density is equal to mass over volume. I want a specific mass. Does that make sense? I want a specific mass, 100 grams. So how do I do that? I will work out that I need the volume then, because I've got the mass, it's going to be 100. I've got the density, 1.53. I'm going to be looking for the volume that 100 grams is. Okay, so V of the solution is equal to, what's that? M over D, which is equal to 100 over 1.53, which is equal to something. 65.36 mils, right? That volume of solution will give me 100 grams of solution. Does that make sense? Happy with that? All right, so now I need to work out the mass of my solute in 65.36 mils. So I can work out the number of moles, oops, let's do that in a different color. I can work out the number of moles of Na2CO3 in 65.36 mils will be equal to CV, which will be equal to 1.6 times the volume in liters, 0.06536, and I should be saving my values. Right. So that equals, divide that by 1,000 times 1.6. 0.105 mole there. I can then work out the mass of that Na2CO3, which will be equal to the number of moles times the molar mass, which is 0.105 times 105.99, which is equal to 11.08 grams. Okay. So now I'm going to go and put that into the percentage weight for weight equation. Percentage weight for weight of Na2CO3 is equal to 11.08 grams over 100 grams, which is just equal to 11.08. And because this is a percentage, it's times by 100, which gets you the same value. That is percentage weight for weight. Okay? So the main ideas is that you have to use your density to work out the masses of stuff for parts per million and weight for weight. All right? Do you want to go through another one? Another set? Okay, let's go through this 120 parts per million of nickel, and then I'll let you go and do your own work. Okay, 120 parts per million of nickel 2+ ions. So now I need to work it out in moles per liter and stuff like that. So if you are given parts per million, you have to be given a density value. So I'm going to give you a density value of 1.02 grams per mil. is the density. So now we can work out all the other stuff. So we're working out for mole per liter. Right. Where do you think we should start? Where should we start? Number of moles of? No, we can't start there. What information are we given? We're given a density, we're given a parts per million. Mass of? Of what, sorry? Of the mass of the solution. Good. Let's start with the mass of the solution. Okay, what are we given? We're given a density. What else do we need to do? A volume. What do we do with this volume? How do we get this volume? We are assuming a volume. Okay, so assuming 1 liter, we can get the mass of the solution as that's going to be density times volume. 1.02 times the volume. Should I just write 1? Nope. Needs to be in mils. It doesn't always have to be in mils. It has to match the unit for density. It has to match the unit for density. Okay? So, times 1,000, which is 1,020 grams. Okay? That's my mass of solution. That's my mass of 1 liter of solution. Okay? Now what? Number of moles? Can't get there yet. I have to use the other value, the parts per million. So the parts per million calculation is equal to solute in milligrams over solution in kilograms. So I have parts per million. I have the mass of my solution. I can now work out the mass of my solute. Okay? So let's go start filling in stuff. What can I fill in?
Parts per million.
Parts per million, yep. So I'm just going to rearrange the equation. Mass of nickel 2+ ions is equal to parts per million times mass of solution in kilograms. Okay, so how am I going to do that? So I do parts per million, 120 times 1020. Is that right? No. What should it be? 1.020. 0.020. 122.4. What unit? Milligrams for parts per million. Okay. Now I have that mass in milligrams. I can convert that to grams if I have to, which I do. Okay. Then I can work out the number of moles of nickel 2+ ions by taking the mass, dividing it by the molar mass of nickel, which happens to be what? 58.69. Which happens to be 2.09 times 10 to the negative 3 mole. Now what? I still want it in moles per liter. I've just got moles. Times it by liters? No. Concentration is equal to? Yep, C. C is equal to? N on V, not times V, yeah? So N, my 2.09 times 10 to the negative 3. What's my volume? 1 liter. That's what we assumed from the beginning, which effectively makes that the same value then. Why is that so hard? Oh. Okay. We're going to do that now in grams per liter. Can we use the information that we already have to get this fairly quickly? Yep. So here's my grams. And I know it's in 1 liter, so it's that many grams per liter. That's nice and easy. And percentage weight for volume. Right? Percentage weight for volume. I need to get this into 100 grams. Any ideas on how to quickly do that? Okay, I'll give you a hint. It starts here. Okay, so the ideas are this one here. 1 liter equals 1020 grams. 100 mils will equal 1/10 of that. Does that make sense? 102 grams. Wait, whoops, I wanted it in 100 grams. Whoops. Same concept. I have to divide that 1 liter by something that gets 1020 to 100. Yeah, so I got to divide it by 10.2. So this is a divide by 10.2, and then this has to be a divide by 10.2 as well. So it's 0.098 liters, which is effectively 98 mils. Okay, but it's not the exact value. Okay. I can then also do that same thing, divide by 10.2 over here to get me into 100 grams. So 0.1224 divided by 10.2 is equal to 0.012 grams. Right, and then 0.012 over 100 will equal, times it by 100 again, will equal to 0.012%. We don't use weight for weight very much, but yeah, that's how you would do it. That's a faster way of doing it. However, you can go all the way back to the beginning and use this to get 100 grams, just like we did before. Right? But we don't use weight for weight very often. Okay? We want to do one more. You want to do the next one? This one here? Grams per litre into moles per litre and to parts per million? Are we happy with that? Yeah, Jessel? Yeah, you could do that as well. Wait, what did you say? Yes, that would be the exact same thing, to divide by 10.2. Yeah. Because 1020 over 100 is 10.2. Cool. All right. Where did the 98 go? That's just the volume. I didn't actually need that. I actually only needed the ratio here. I could use this and apply it to this to get this, but I don't really need to do that. Okay, because I already had the mass there. Okay, so that's a little bit about conversions.